postage. AgXeed AgBot, the largest of the three, offered by the Dutch manufacturer. Working here with an Amazon cultivator, very wet clay. So just running around the machine, front to back, we have a bumper at the front, which is designed to cover all aspects of safety, looking out for obstacles in its way. We have LiDAR and radar for object detection. So if you were to walk in front of the machine, it would come to a halt and carry on once that obstruction was moved out of the way. 4-ton front linkage, front mounted implements, seed hoppers, cultivators. Range of track sizes depending on the application that you're working in. So we go down to 30 centimetres, 200 millimetres for row work, up to 900s for those needing extreme flotation, increase of soft soils, or extra traction for heavy draft loads. GPS controlled, fully autonomous. You see the receivers on the top, so the Novotel receivers left and right, and the central white fin is for telecommunications, for remotely dialing in and monitoring the machine. There's also cameras front and rear, so regardless of where you are in the world, you can see what's going on. And then finally, right at the top, the LiDAR that looks around you 30 meters, looking out for obstructions or people around. The rear end is exactly like you'd expect from a conventional tractor, category 3 linkage, with an 8-ton lift capacity, or 17,000 pounds, 4 hydraulic remote valves, and 150 horsepower PTO. Full Isobus connectivity. So to answer the question from Canada, slip control. Slip control works just like any conventional tractor, and will raise the implement as it starts slipping. Okay, so this section we're going to look at the controls. So while you are bringing the machine into the field, setting it up, adjusting it for the first time, you can use this controller. Once you're happy with it working in autonomous mode, you can then turn that off and head away, leaving it working fully safely, unsupervised. So first item is the rear hitch. How do we use the rear hitch? So by pressing the button shown here on the bottom left, press and hold, and we use the levers at the back, or the levers at the back, to raise the implement. So with the implement out of the ground, steering. So to go forwards and backwards, we first need to take the handbrake off. Taking that off, we move it to the left. This raises the engine from idle and takes the handbrake off. We can then move forward with the left lever, forwards and backwards, as you'd expect. And then using the right hand joystick, we can turn left and right. In exactly the same way, the front linkage, we can control that using the same button but with the left hand finger shown here. You see the front linkage going up and down. Also hydraulic top link, front and rear, controlled in the same manner. So once you're in the field, how do you put the machine into autonomous mode? So we need to get the machine lined up roughly in the right direction. It can be pointing in the wrong direction or any which way. So we press this button here, button 1, and we push the lever forward. So this is working in an almost auto steer like manner. We are providing the forward speed, but it is driving itself to the starting point or the resume point. So we obviously cancelled autonomy here. So we're nearly there. We can see on the controller how many meters we are from the work point. Once we've got to this point here, step back a bit further, we can then resume autonomy. See from the controller, we press button 3 and it says ready to start, left joystick left to start autonomy. And there, the implement comes down. And while we're in this mode, the remote control can work up to 200 meters. So what we need to do now is to turn off the remote control, and from there, power it off. The remote control goes off, and there we are, up to 20 hours of operation on a single fill, working away. Any questions you've got, please pop in the chat box. So Melvin's question, how do we measure the outside of the field? So, correct. We measure it using a GPS receiver, generally on a pole. You can drive around the outside of the field in a truck, pickup truck, or you can walk it with a handheld GPS. The outside boundary is then loaded into the portal up onto your phone or computer. At that point, we also need to measure any telegraph poles, any trees, rivers, ponds, and that you can then see that in the portal, so you can plan around those. So yeah, good question. Once that's in for the first time, while you're doing that, you also need to load any implements into your digital shed. So this 3-meter Amazon Centrio here, we load it into the digital shed. And then from there, once you have the implements loaded and all your boundaries, simply a matter of selecting which field you want to go and work. You can make that as complicated as simple as you want. Here you can see we're missing a pass. So we've been and done every even pass, and we're now filling in every odd pass. You can adjust that to skip as many as you wish. You can turn the direction of work as well, just like any modern tractor. And having planned that, it'll give you a very exact finish time. You program the turning speed, the height of the implement, fully customizable and then repeatable year on year. The GPS unit we don't actually have one right here. It's called an MLED. They're about $2,500 to €2,500, $2,000. That just needs a SIM card in it to connect you to your VRS system, the same as what the AgBot uses. Yeah, AgBot dealers can map this for you to start with generally, and then train you to map your own boundaries as you like. So you can see at the top here, the lights spinning around at the top. By law, autonomous machines require flashing lights, so you can see it's green and amber. What Will's going to do now is walk towards the machine very slowly. You might be able to see Will is now standing in front of the machine. The lights on the top, as you can see, should be changing purple, and those purple lights indicate that the machine can see Will and he is becoming an obstruction. We get an audible warning as well, requirement. As Will's moved out of the way, you can still see a few purple lights there. Really helps bystanders, people, animals know that AgBot knows that you're there. Outputs, so we do find it, while it's 160 horsepower, the tracks can get so much traction compared to a conventional tractor. So it generally competes around the 160, 180 horsepower range. Here seen achieving 110 acres a day if you have fields big enough to do that. Should be looking around 110 acres a day. That's about 45 hectares. But again, having fields large enough is obviously the biggest challenge to keeping these AgBots busy. So monitoring the implement. So this implement here is same as the implement shown at Agritechnica. And Amazonia are working on integration for smart implements. So the machine shown at the show had tip monitors to answer Farm 13's question. So this had the prototype we saw at Agritechnica had 5 different sensors. There's a packer roller sensor to make sure the rear packer's always spinning. We had tine sensors, to your question, that can make sure that the point or the tip is not lost. There's also deflection sensors on these spring-mounted tines to make sure if a spring is broken, we also keep an eye on that. So yeah, 110 hours is in a 24 working hour day. Across to show you the remote on here. So this is what you see on your phone. So these are all compatible with iOS, Android phones, tablets, PC and Mac. So here's an example, difficult to see. We have the front camera at the top, so you can see the 2 GPS receivers in the front weight. So yeah, hopefully you caught that, but you can monitor the machine remotely. You can also pause the machine if you want it to stop for any reason. All traction this way, and then turn the cameras on, see the situation in hand and restart from remotely without being in the field. If this continues, you will need to go to the machine and get it restarted. So Will's just going to do that, show you that again. He's going to walk to this side of the implement, look for the lights on the top. It will slow down once he disappears. So you can see the purple lights on the top, indicating that Will is standing in its way. He moves out of the way. The purple lights continue. The LiDAR can see objects and animals up to 30 meters away. Carry on with its job. Working in some really wet conditions here. We shouldn't be here, really. Any questions, head to the website.